Okay, this video is to cover an example where we are writing pseudocode to implement the following algorithm that's described by this diagram. Okay, so in class I told you that the steps for doing this are to label the outputs of summers if they're not already labeled. And also label the output of delay elements. Okay, so this particular summer, this one right here, is already labeled. The output is y of n. All right, this summer, the output, we can call that W0. All right, so that'd be the output of this summer. All right, so we have the summer outputs labeled. Now we label the outputs of the delay elements. So this would be W1, W2, and W3. I mean, I use W's. You could use anything you wanted. But this is, the way I do it. All right, so once you do that, all right, so that's essentially step one. The next thing to do is to start writing the pseudocode by looking at equations for the output of summers. Okay, you start off to the right, to the left, and work your way to the right. All right, so I'm looking here. I'll highlight these outputs I'm talking about. Here's the output of the summer. Here's the output of this summer. We're going to look at equations for both of those outputs. All right, so taking the first summer into account, all right, I'll put a little green line here. I see I have this input coming in, I have this input coming in, and I have this input coming in. So the three green highlighted lines are the inputs. All right, so I look at the corresponding label points to write down the output of the summer. All right, so for each x, remember x is the samples of the input, we're going to do the following. Okay, we're going to write down the output. W0 is equal to, so first of all, we have x of n, and then second of all, we see that this green line here connects from the point W2, right? It's connected at that point. So this would be plus, we look at the coefficient along the way. The coefficient along the way is -3, so it'd be plus a -3 W2. All right, and then the last green line, which comes from W1, goes this way. All right, so that would be plus 4 W1. All right, so we're done with that output. All right, so we go to the next output. The next output is y. All right, so y is equal to, I look at the green lines coming into the summer. Here's one, and here's one. Okay, so in this case, y is equal to, I think you can see it, 2 W0 plus 6 W2 minus 3 W3. Okay, so at this point, we're done with the first two steps, and the last step in this process is to, step 3, update the delay lines. Okay, so in this particular case, I have three delays. All right, so I would need to do this in sequential order. W3 is equal to W2. W2 is then W1, and W1 would be W0. I have to do this in reverse order, or else I'll write over one of those variable names. Okay, and then that's the end of the do loop for that particular sample of X. All right, so as we have incoming samples, we just do this algorithm over and over to implement this block diagram.